Hello everyone and welcome back to a new video in our modeling, analysis and design of reinforced concrete building structures, in which we are going today to be talking about the modeling of the ramp, at least the principles and planning of it, because it turns out it will take a little bit more time and I don't want just to start modeling right away because I want you to have a concept of what we are going to do and how we are going to achieve it. So with that being said, well, sit back, relax and enjoy the show. Alright, now before I start, you should know that if you are new to this channel, this is a part of a multi-parter in which I'm trying to model a structure and give also running commentary on the points that I have. Of course, as all civil engineering models, there isn't only one way of doing things, so please notice that whatever I say here is my personal take on it. Feel free to discuss that in the comment section and suggest improvements if you have them. I have been reading the comment sections, people are very active there, and I really appreciate every single point. Now I'm gonna give a quick rundown of the things I thought are odd in this, because this is an architectural drawing, as part of a series I will be linking on the top right. And what I found strange here is that, well, first of all, the width of the ramp seems to be only accommodating one car. Although it's a multi-story car park, I think it was like basement 1 and basement 2. So the problem is that you can imagine that somebody just drives down and he's being met by another one who's driving up. So how do they know that they exist? Now, one of the options is to provide a smart system where you have sensors. If a car drives, you would get red lights on the other side. But well, I still thought it's really odd and it just didn't make sense to me. That is my first point of criticism. The second point of criticism is, well, that there is no retaining wall because the structure is underground. So we had to make a retaining wall, which we have done successfully. The third criticism point is actually that the structural system of the ramp is not even mentioned. Now, usually when an architect suggests a ramp, he sits down with a senior design engineer and tries to lay out the structural system of the ramp. It seems that it's a block here that was used, so I'm kind of disappointed because it doesn't show anything with regard to columns and column setout and how even to do that. The second thing that kind of annoys me is that there is an opening here. Although we said that it's really small, I mean, you need to understand that the turning radius, like cars sometimes cannot turn that tight. Like, why do you have this opening? It's better to have like just one wall between them that basically just allows for more width, just in case. So I'm kind of not really happy with that. One thing I forgot to mention is that it's very hard for us also to have a ramp because there is a retaining wall, right? The ramp needs to be carried somehow. Now, having the retaining wall carry the ramp is really odd because you would have to provide some links in the wall, and it's really a mess. You don't want to do that. Also, car ramps need to be like sturdy enough. So I mean, connecting it with a 250 millimeter wall that is already under pressure from soil, I don't think it's a nice idea. I think this is not good. Well, I actually went there on the site and brought to you like a ramp that I have seen. Now, this is a car ramp, although you cannot see it, and this is part of a structure for car parking that is part of a bigger tower. And it's actually one of the biggest towers we have in our current location. Now, information aside, we want to understand this structurally so that we can suggest something adequate for this mess. Now, that's why I need like this video, because, well, we need to understand it structurally. So, well, let's take a look on some car ramps I have visited, and this seems to be the case everywhere in my current location. Now, this is a car ramp. You don't see it because the cars are actually driving here. They are driving behind this little wall. They're driving up and they're driving down. And the car ramp's width is actually big enough to maintain two cars. Like, you could have a car going up and a car going down, and the road is wide enough to basically allow for both. Also, delta H here is 3.5. This is important for vertical clearance because, well, you must for each car park provide this maximum height sign that says that the car park can only sustain 2-meter heights or something. The car park's ramp thickness is actually not what you see here. This is the carrying beams thickness. The car ramp's thickness is actually smaller. I don't have access to the drawings because are classified, but at least I know that the car ramp here was 300 millimeters of height, which means that hidden from your view, there is a car ramp, like you can, if I just draw the section, hidden from your view, that's somehow here, is the section of the car ramp slab, and the car ramp slab had a thickness of around 300 millimeters. Now, the car ramp slab is, of course, not floating in midair. You need to carry it somehow, and it's not a good idea, as I said before, it's not a good idea to carry it on the wall here, because we have a retaining wall here, and the retaining wall is just 250 millimeters. And like it has a certain objective to retain soil. So why would you even allow a car park to be added to it? Of course, you could disagree with me. You could just suggest something different. I am totally all ears for your suggestion. Now, with that being said, if you look here on the things I visited, you can see that this car ramp is being straight and is carried by two big beams. As you can see here, those big chunks of beam. Let me just do that. Those two chunky beams, this one, you can see it here. There we go. And this beam is inclined as well as some columns. Now, of course, the question here is, how would you construct that? Notice that we are doing modeling, analysis, and design of structures, so I don't even need to explain how it's constructed, but since we are here, why not explain that? You see, the construction of a car ramp is really a tedious task. The idea being that you would have to cast your columns in stages. Like here, you would have to cast your column all the way up to the level of the car ramp, and this needs setting out by a surveyor. You cannot just wing it. So actually, you would have columns that look kind of like this. Now, not really inclined. Inclined is not a must here. You could, for example, cast the columns all the way horizontally until, well, this place, and cast the rest with the beam. That's not an issue. But the point being is that it needs to be set out. You would have columns that have different heights. Now you cast those columns, of course, with the other columns. And then you have to do the formwork of the beam. Now because the beam is inclined and straight, the formwork is not that dangerous, but you still have to set it out with surveying help. A quick winging it will never work. So stage one is basically to cast your concrete columns, those dudes. This is stage one in the construction. This is really a tedious and daunting, time-consuming task. Stage two is to do the formwork and cast your beams. Now notice, and a lot of times you would have a pre-stressed beam or even pre-cast, but we are not going to do this because in this video series I'm trying to have simple reinforced concrete. I am thinking of making pre-cast series later. I don't think Robot has the ability. I need to research that, but I have some softwares I can mention. Anyway, you cast your beam as well as your slab of the ramp. And then in stage three, you could continue the casting of the rest of the column. And then, of course, stage four is you continue your general operations to cast the top slab. This is a system I have seen in action. Now, of course, different regions have different application or different ways of doing things. Feel free to tell me in the comment section if you want, if you have any idea or any different way of doing it. This is at least the way that makes sense to me. Now here, this is a single ramp that has two-lane traffic. In our case, we don't have a single ramp with two-way traffic. We have a single ramp with one-way traffic. So we need to understand how to do that. You see, this needs planning, and my plan kind of looks like this. Kind of. Allow me to elaborate. You see, in my structure, I would have to have a central column. So those things, this is a central column. And I would have a column on the side here. And I will have another column on the other side here. So, of course, I'm not drawing 3D, I'm drawing 2D, but you can predict how it looks in 3D. So the central column, which I am going to plan to have here, is going to carry both ramps. So it's going to be a nightmare in casting. I will explain to you the construction method later, because see, when you model something in Robot, you always have to keep an eye on the construction process. This is what people have a blind spot for. For some reason, when you are a junior engineer, you tend to have a blind spot of the construction process. And then, of course, you would have to modify your drawing or your modeling over and over again to account for the construction process. Now, I will tell you my vision, and I will tell you the intended construction process, And that's basically the main goal of this video. The main goal of this video is to discuss how I would approach this ramp for this specific problem. And that's why it might be a little bit short, but I kind of want to lay out the planning here before I start modeling. Now, first of all, my plan here is to basically change the entire ramp by having two ramps that are adjacent to each other. So I'll draw a polyline here to show you what I mean. So I'm planning a ramp that is like this, okay? And this is basically one side of the ramp. And here I'm not even planning a circle. I'm planning a horizontal thing, slab, and then it continues. That's my plan for the car ramp. I will tell you why I'm planning horizontal here in a moment, and I will tell you the pros and cons of doing that, but I will tell you later. Now we are planning still the columns. The ramp itself and the setting out and the layout will be explained in a moment, so just wait for it. But for now, I'm planning that I would have a ramp, since we are having one-way ramps, a ramp that is adjacent to the ramp to the other one. This also provides a little bit of more turning area and more maneuvering when a car wants to turn, because I somehow am not really happy about those 8 meters. You would have to restrict traffic and allow only certain cars to enter. Anyway, what I'm saying is that's my plan, so you need columns for that. Now, my columns, I'm intending to have them here, like one here, and I mean on this line. I don't know how many columns I have. I still need to plan this, but this is not of today. This is something I will do in Robot, what kind of makes sense. But I'm planning to have columns like this, maybe 3. I'm drawing them a little bit awkwardly spaced, because my point is not to do some like detailed drawing. I would still show you how to import this in DXF file later, but for now I'm just doing an approximate drawing. So I'm planning to have this big columns in the center, and those big columns shall carry those 2 ramps. Now this ramp should actually be touching the column, so there must be a spacing. I'm thinking of construction now, and the other ramp would have basically touching it like this. You need some spacing here because those are 2 planes of motion. There are 2 different heights. Like this is different height than this. You need to keep a 3D mind here. It's really hard, so that's why you need to visualize it. But I still cannot visualize without explaining to you what I want to do. So I have central columns, and I have some side columns here, and some side columns here. The central columns are what you see in red here. And the side column here is what you see in, I don't know what this color is. And those side columns are what you see here. Okay, now this is my plan. Now, in terms of construction, well, the blue columns will follow actually the same construction principles that we have explained for the central columns here, i.e. you construct a part, and then you construct the ramp, and then you construct the rest of that thing. That's an easy task. Similarly, for the right side columns, you construct a part, and then you construct the ramp, and then you construct the rest. Notice the difference in height that I have drawn intentionally in the steps. Well, because I'm assuming now that the car ramp goes like this, like up like this, and all the way spiraling up. So a car would go up and spiral around here. This means that the ramp here is low and the ramp here is high. I'm not really sure how the ramp is. Maybe it's vice versa, and I think it's vice versa actually. Oh yeah, see, it goes down from the left side. So in reality, the construction steps would be a high ramp here and a lower ramp here, because the car is actually coming from top and spiraling or going down, going around the red column and then going down here. So that's my construction steps. Now for the left column, I hope it makes sense. If it doesn't make sense, tell me. It needs, and you might even have to check out this part multiple times. Now the challenge here is in the construction process of the central column, because the central column is going to carry 2 ramps. What I mean by that is, well, in one part it's going to carry the ramp from this side, and from one side it's going to carry the ramp from this side, because the car starts like this, going into the screen, goes down into the screen, rotates around the red column, and goes towards you. This is basically the motion I'm describing here. It goes into the screen, rotates around the column, and goes down. That's exactly what happens here. The trip from the right side to the left side is this trip down. The trip around the central column is this trip. And the trip from left to right is, well, this trip. Remember, This is a suggestion from me to you. Different regions have different construction practices. So what I would do is I would construct this part and then basically construct this part together. And by this part, I mean this part repetitively, because there are multiple columns at different heights. You get the idea. And then cast this ramp. And then as phase 2, I would have to construct or to cast this part, and this part. And then phase 4, I forgot, I lost count of numbers. I would construct this part. And the final phase, I would construct this part and construct this part. You see, I'm always trying to construct something in one go if I can. Like here, I did not construct up to this height because I wanted to construct it in one point because there was no need to make a height difference here. But you get the idea. That's my construction process that I want to do. And that kind of makes sense. And that's why this is my structural system that I'm going to implement in Autodesk Robot. Now, the implementation in Autodesk Robot is going to have to wait another time. It's going to be challenging because you will have a ramp, and I need to remind myself that I should disconnect the ramp from the basement wall. It's going to be really spicy. I think like my plan here is going to have a model here in DXF and a more regulated model, and basically export it and then draw it. But at least I have a good game plan that I'm going to follow, so I hope it makes sense. One final thing I have not explained before is that this seems to be a circular ramp, a spiral, a helix. And there are advantages and disadvantages for it. Now, if this would be a professional work where I am like dumping hundreds of hours without explaining to YouTube, I would make a spiral here. But since I'm explaining it for YouTube, I'm going to simplify it to a horizontal curve. I might do another spiral in the future. I think I had a spiral staircase, and I think I have a video for that, so I will be linking it on the top right. Spirals are notorious in modeling, and my goal here is not to do the spiral. My goal here is to show how you can model a car ramp and the different aspects you need to consider. Modeling spirals has been covered before. I will not do it again here, and I will do a horizontal curve. But still, those have real-life implications, by the way, because both are possible. The real-life implications of having a spiral versus having a horizontal curve are as follows. Now, please notice that you need to understand, first of all, what I mean by spiral and what I mean by horizontal circle. To understand this, I need to get back to this drawing where I drew the movement of the car. If you have a horizontal curve, the car would be going down, so I'm describing the movement from the right to the left. The car would be going down like this all the way until this here, this point. And then it would not go down. It would turn around horizontally. So it would turn around the circle horizontally. Now, in that way, the rear lights are visible to you. When it turns around now, the front lights are visible to you. And then it will go down the ramp all the way until it reaches this floor. This is with a horizontal circle. If you have a spiral, then it would go down like this until it reaches this point. And then while it's rotating around the column, it's still going down. So it's spiraling down. And then it continues going down. Now, those are two approaches. I would choose the horizontal circle approach because it's simpler for modeling. And I already have a video for spirals, so you can check that out. But the most important point is to understand that when you do something, it has consequences in real life, in your construction. Now, there are advantages and disadvantages to both approaches. Allow me to explain. Of course, the advantage of the spiral, meaning that the curve here is not horizontal, is first of all, it looks cool. Well, that's a good thing, actually. And the second thing is that if you have a spiral, then your slope decreases. Because what is the slope of the ramp? The slope of the ramp is the length of the ramp divided by the height difference. And by the length, I mean the sloping length. To understand this, I need to draw again here. Imagine you have a ramp. Now, this is a ramp from the side view. So you have this going down. And then you have a spiral going down. I'm not good at drawing. And then you have here the continuation of the ramp going down. So to find the slope here, To find the slope, you would need to find the delta of the height, so dh, over the delta of the length, or dx, meaning height difference divided by length. That's what a slope is, delta y over delta x. And the length here is the length that contributes to you going down. And since the helix here is spiraling down, the length is actually the length of the ramp, the length of the spiral, and the length of the other ramp. This means that the slope for a spiraling curve is actually lesser and milder and better for cars, because your length will include the helix or the spiral here because it's going down. Now, when you do a horizontal curve, your ramp looks like this, because the car goes down and then it rotates horizontally in this point and then it goes down again. So here the slope is a little bit steeper because you lost the length of the helix. This is an advantage that you find in the helix or the spiral that you don't find in my approach, which is the horizontal curve. Now, this is an advantage for the helix. It's an advantage for the spiral that you have a milder slope, and disadvantage for the horizontal curve that you don't have a milder slope. You have a slightly increased slope. What about the disadvantage for spirals? Well, it's all about working. It's all about laying this out. Laying this out or setting this out is going to be a nightmare. Why? Because since it's a spiral, you need really skilled workers, which of course cost money, and really accurate equipment to lay this out. Also, if it's a spiral, then this must become a circle, which means you still have complications when it comes to the beam here because it has some twisting and whatnot. Because when you make a spiral, you cannot make a spiral with a rectangle or square like this. You would have to have a circle, a perfect circle, I might add. So this is a nightmare when you set this out in real life, when you want to do your formwork. Trust me, I have worked on spiral staircases, something that is much easier than a spiral ramp, and it was a nightmare. I did not have the skilled workers back then when I was like a junior engineer, and it was really not nice. What about the horizontal curve? If you have a horizontal curve, then first of all, you don't need to have a circle. You could just make a rectangle like this. This means that you can gain extra space here that is necessary maybe for dealing with a tight curve or with newbies or new car drivers. Now, of course, if you have a horizontal curve here, you can use the entire rectangle, and the laying out of it becomes much easier because it's just a flat surface. You see, curves are in layout the worst nightmares for surveyors, especially if they are 3D curves. So in my approach, it's actually much easier, in practical terms, to lay it out. Of course, to be honest, the only reason why I'm doing this horizontally is not because of practical issues, it's because I want to save some time and some explanation time and some nightmarish time by having a horizontal surface. It's much easier to model in Robot. But of course, I modeled spirals before, so feel free to do whatever you want. So yeah, I know this is a Robot series, but in this video, I did not do anything Robot, which is kind of odd. But I think that my point here is warranted because this is a theoretical video I have to do, because what is the point? I mean, you know that Civil Engineering Essentials here has a philosophy of not just dishing out robot stuff, but actually explaining on the go while we are doing things the way we are doing. I realized I might have hurt some of your eyes for those of you who are having the dark mode, because I'm switching between dark AutoCAD and bright Robot, so I'm sorry if this strained your eyes just now. See, I care about my viewers' eyesight. But back to the dark to kind of relax your eyes. You see, the philosophy in the Civil Engineering Essentials channel is actually to not just show you how the software works, but actually to explain to you why we do the things we are doing. Now, to be honest, for a ramp, I was unable to do this on the fly, like I was unable to explain and lay out the ramp, because I had to give you the full picture, the entire idea, before I start laying out the ramp. There is no way I can just start laying out the ramp without you understanding the full process. Now with the full process out of the way, in the next video I will be doing the ramp with little commentary, just some practical issues in Robot. So yeah, that's everything I wanted to talk about today. I'm really happy that you joined me. Before I finish, I want to give a horizontal curved sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as the support of the channel is priceless to me and enables me to provide you with videos with a certain quality and hopefully on time, something that I am a little bit struggling with this recently. And for that, I am forever thankful. Of course, if you have enjoyed the video and you found it beneficial, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing, because YouTube needs the constant stream of sacrifices in terms of subscriptions. So please subscribe to increase the reach of this channel. With that being said, and as per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.